Assalamualaikum and greetings to all who watch my video. My name is Hartini Binti Zamzan with matric number AN190107. My supervisor is Professor Madiati as Dr. Nurhanis Hayati Binti Hairum. In this video, I will present my final year project 2 entitled Different Ratios Formulation of ZnO-MO Nanofluids for Textile Wastewater Treatment via Membrane Photocatalytic Reactor, MPR. First of all, this is my poster for final year project 2. In this presentation, I will include an abstract, literature review, methodology, results and discussion, and conclusion of my project. Basically, this study proposed to investigate the effectiveness of ZnO-MO under different ratios for textile wastewater treatment via membrane photocatalytic reactor (MPR) due to the presence of dyes that are not easily degraded by conventional treatment procedures, and these treatments provide only phase transfer or partial degradation for dye wastewater. This study aims to formulate the different ratios of ZnO-MO nanofluids, which is 3:1, 5:1, and 9:1 to leaf extract of Mangifera Odorata MO. The performance of 3 different ZnO-MO nanofluids in treating textile wastewater were successfully being observed via membrane photocatalytic reactor (MPR). The treated textile wastewater were analysed in terms of its pH, turbidity, chemical oxygen demand, COD, dissolved oxygen, DO, and colour intensity. The mechanism of membrane fouling was characterized using model fitting according to the theory of blocking filtration laws. Okay, for the introduction, the textile industry's untreated effluents contain a wide variety of organic contaminants, with textile dyes being the most abundant. There are numerous modern techniques in use today. However, due to the presence of dyes that are not easily degraded by standard treatment procedures, effluent is highly contaminated. In addition, this technology provided only phase transfer or partial degradation for dye wastewater. Zinc oxide's photocatalytic potential has been intensively investigated due to its favorable properties, which include a high excitation binding energy, a large surface area, a high degree of reactivity, non-toxicity, photosensitivity, and chemical stability. Green synthesis of zinc oxide as photocatalyst in MPR due to its evolution, which harmless chemicals are produced using eco-friendly and biosafe reagents. It is also a feasible alternative to physical and chemical processes. Mangifera Odorata, often known as Queenie or Queenie, a mango variety distinguished by its brilliant colour and exhibited antioxidant and antibacterial activity. The study aims to formulate zinc oxide nanofluids in presence of Mangifera Odorata for textile wastewater treatment via MPR. Okay, for the literature review, water contamination due to the failure of the textile industry to appropriately discharge their wastewater is currently one of the world's greatest challenges. Textile industry are significant contributors to the overall economy and environmental pollution, as stated by Olisa et al. 2021. Effluents containing dyes are significant environmental pollutant that also affects human health, as the textile industry generates vast quantities of highly coloured wastewater containing a variety of persistent pollutants. Zinc oxide, being one of the metal nanoparticles, possesses important characteristics including a large surface area and a high absorption capacity for heavy metals from aqueous media. Utilized extensively in the absorption of impurities, zinc oxide has unique physical and chemical properties, processes, and mechanisms. In addition, the zinc oxide porous support provides a distinct separation, as stated by Hartini and Salary 2021. Due to the favorable features of zinc oxide, its photocatalytic potential has been the subject of extensive research. The photocatalyst uses ultraviolet, UV, visible or solar radiation to generate strong oxidants that degrade persistent organic pollutants in the water, as stated by Ashley et al. 2021. Photocatalytic advanced oxidation processes can be combined with membrane filtration processes to create a membrane photocatalytic reactor, which is MPR, which accumulates pollutant near the catalyst surface before degrading them by photocatalytic degradation. Membrane photocatalytic reactor MPR is a system that combines photocatalysis and membrane filtration to generate a high-quality permit. Strong oxidizing radicals are produced by photocatalysis, which degrades the pollutant. Membrane fouling is the build-up of various substances in the pores or on the surface of the membrane, which affects the amount and quality of the permit. Fouling of membranes is typically characterized depending on the type of foulant or location of the fouling. Foulants fall within the categories of particulate, organic, inorganic, and biological microorganisms. Fouling can happen either internally or on the membrane surface. 4 fouling methods exist in broad sense, which is complete blockage, intermediate blocking, standard blocking, and cake formation. Next, for the methodology, chlorine, chloride and urea were weighed with molar ratio of 1:2. Then the mixture of chlorine, chloride 129.6 gram and urea 120 gram were heated in an airtight flask by setting the temperature of the hot plate to 80 degrees with constant stirring at 120 RPM with a magnetic stirrer in the beaker until a homogeneous colorless mixture was formed, which is called deep utilised solvent DES. Then the DES solution was cooled until it reached room temperature. Then 4.38 gram of zinc acetate and 60 gram of sodium hydroxide (NaO) were dissolved in 60 ml of DES solution. Then the different ratios were formulated by different loadings of MO, which is 0.02 ml, 0.12 ml and 0.0067 ml that were added into the mixture of 3 conical flasks. Next, the conical flasks were wrapped fully by aluminium foil and were stirred for 24 hours at 250 RPM using an orbital shaker to increase the production of zinc oxide. And then the ZnO-MO were ready for characterization via FTIR, as well as ready to treat the textile wastewater via MPR system with absent ZnO, commercial ZnO, ZnO-MO with different ratios, which is 3:1, 5:1 and 9:1 were conducted via MPR. After completed the treatment via MPR, permeate's quality was analysed in terms of pH, turbidity, COD, DO and colour intensity in order to achieve the second objective of this study. Lastly, the membrane Fourier mechanism were elucidated via MATLAB R2022B by using blocking filtration laws. The value of model fitness degree and fitting parameter constant were recorded for further discussion. Okay, for the result and discussion for the characterization of ZnO-MO nanofluids, in the obtained FTIR data were found the functional groups of hydroxy group, carboxylic group, carbonyl group, ZnO, CH stretching and CC ring. All ZnO-MO samples exhibit a nearly identical FTIR pattern with slightly varied values. Okay, for the normalized flux of different photocatalysts, in order to recognize which type of photocatalyst is better during the textile wastewater treatment via MPR, the normalized flux has been calculated and resulted. It shows that ZnO-MO with 0.0067 ml of MO or ZnO-MO with ratio of 9:1 has the highest normalized flux and performs the best in terms of dye degradation compared to the ZnO-MO with 0.02 and 0.12 ml of MO. Okay, for the effect of different photocatalysts for analysis of pH, ZnO-MO with 0.02 ml of MO has the lowest pH compared to other loadings, which is 11.90. Even though it is not suitable for discharging the treated textile effluent into the environment. However, according to the graph for figure normalized flux, the optimal loading with the greatest normalized flux is photocatalyst ZnO-MO 0.0067 ml of MO. Clearly, an increase in pH up to 8.19 and 12.29 causes an increase in photodegradation activity. Hence, the use of ZnO-MO as a catalyst is better suitable for textile effluents with pH values. Okay, for the analysis of turbidity, all photocatalysts are below the range of turbidity with ZnO-MO with 0.067 ml of MO being the second lowest, which is 1.02 NTU based on the National Water Quality Standard NWQS, which is less than 5 NTU, which is good because it shows high water clarity and good for discharging the treated textile wastewater to the environment in order to protect the water quality and aquatic life. Okay, for the analysis of chemical oxygen demand (COD), it is demonstrated that photocatalyst ZnO-MO with 0.02 ml of MO has the least amount of COD and is in the class 2 of COD level based on National Water Quality Standard and WQS, which needed conventional treatment. Whereas ZnO-MO with a 0.0067 ml of MO as photocatalyst has the second highest amount of COD. This may be attributed to the rise in organic content in the water. Okay, for the analysis of dissolved oxygen, it can be seen that all of the photocatalysts are deemed acceptable due to their high concentration of dissolved oxygen, allowing for the safe discharge of treated textile wastewater into the environment in order to protect the water quality of the environment and aquatic life. ZnO-MO with a 0.0067 ml of MO has the highest concentration of dissolved oxygen, which is 11.31 mg per liter when compared to the other photocatalysts. The higher dissolved oxygen concentration for ZnO-MO with 0.0067 ml of MO may be attributable to the breakdown of H2O2 with the addition acting as an source of oxygen. Okay, for the analysis of color intensity, the photocatalyst with the lowest color intensity is ZnO-MO with 0.0067 ml of MO with 90 ADMI, falls in the range of class 2 in National Water Quality Standard and WQS and required conventional treatment before being used as water supply. This may be because the treated water contains fewer dissolved and suspended substances compared to other treated water by other photocatalysts, ZnO-MO with 0.02 and 0.12 ml of MO. Okay, for the mechanism of membrane fouling, the efficiency of ZnO-MO with 0.0067 ml of MO in MPR was successfully determined for mechanism of membrane fouling using model fitting according to the theory of blocking filtration laws by standard blocking mechanism, which is 0.9656 and affected to the lower rate constant, which is K standard blocking 0.0017, which resulted in steady decline in permeate flux. Okay, for the conclusion, the zinc oxide were successfully synthesized in the presence of different loading of MO, which are 0.02, 0.12 and 0.0067 ml of MO. The result confirmed that ZnO-MO with 0.0067 ml of MO has the best final normalized flux among other photocatalysts. The efficiency of ZnO-MO with 0.0067 ml of MO in MPR for the treatment of textile wastewater may be described by the standard blocking mechanism and affected by the lower rate constant K standard blocking, which resulted in a steady decline in permeate flux. Further research should be conducted by incorporating ZnO-MO in the design of water treatment plants in order to make photocatalytic degradation more practical and commercially viable. Various additional parameters such as biochemical oxygen demand (BOD), total suspended solid (TSS), and total dissolved solid (TDS) can be analysed on the treated textile wastewater. That's all from me. Thank you.